All right, we'll get started even though there aren't very many of you here. You all matter enough to me that we'll just go with the people that are here right now, and anybody else can catch up on the video. So today we're going to go through all of the Module 6 content, and I'll introduce the assignment. And then next week we're going to go on to Module 7. So this is going to be probably a lot of information, but don't forget, you can go back and review the video. You can code along with it. Also, there are a couple of code snippets already uploaded to Canvas that I'll be demoing in class. If you want to follow along on your computer, you can do that, or if you want to get those later, you can. So today we're going to be talking about custom functions. We've talked about functions already. We've used the word before. The print function is one that we've used quite extensively. The input function, right? A function is a command or a statement or a keyword in Python that just does something. It could be something complicated. It could be something simple. Sometimes a function takes input from us in addition to the function name, like print. We give it what's called an argument, and we tell it what to print inside the parentheses. We give it a string or an object, and it prints that object. That's called an object or a parameter. You'll hear me use those words pretty much interchangeably, and they're kind of the same thing as far as Python is concerned. But those parameters or arguments are a way of supplying additional information to functions. We've also talked about functions in terms of what kind of function it is. It's either a do something or a return something function, right? It either does something like print something to the screen, or it sends back information that we might need or use further down the program. So today we're going to start talking about building our own custom functions. And our own custom functions are ways of taking a whole bunch of code and stuffing it into a single command that allows us to do something that's complicated in a very simple way. The nice thing about custom functions is that it's going to take your long code. You can take a program that's like this long and squish it way down so that your main code structure is very simple and very short, which makes it easier to read your code and makes debugging a lot easier as well. So a custom function is really nice in that way. The downside to a custom function is that it's a little more complicated. It's another layer of complexity that you have to sort of think about and manage in your brain. So we're going to go through some of the aspects of custom functions, and then I'm going to talk about the assignment for this week, or for this module. So Python obviously has built-in functions. Custom functions are ones that you write where you can group complex routines or commands into a simpler command, and it can help your program be more readable. For example, we just finished the ATM assignment, and this might look like a snippet from the ATM assignment where we have like a deposit amount. It's a string right now, but that's okay. Later on, we'll change it to a float. Deposit amount and an account called checking. The reason I put this as a string is to emulate it as if a user input that using an input statement. So it would be a string when they input it. But we have a deposit amount and a check and an account. And using those, we can go into this if else structure where we use the account and the amount to figure out like the deposit and all of that. That's fine for two accounts. It doesn't look too scary or too complicated. But the problem is, what would this look like if we had 100 accounts or 1,000 accounts? Or maybe we wrote a program for an ATM where you could add accounts on the fly. How would we expand our code to make that work if we're adding accounts on the fly? We can't do that. So there's some real limitations to this kind of structure, in addition to the fact that after a while, it's not only is it long, but it's very, very redundant. I mean, you can see these lines are very similar, right? They're almost identical, except we have different checking accounts or different accounts named, but they're doing kind of the same thing. You take the deposit amount, you turn it to a float, you add that to the checking or savings account, and then you print that new balance. What if instead of this, we could do something like this, where we have the amount that we're going to deposit and we have the account name that we're going to use. And instead of that long structure of code, we could just say, do the deposit this amount into that account. And then it just does it for us. That's sort of like what the power of a custom function can do for you. Because we could create this function now, and it doesn't matter if we have 100 or 1,000 or 1,000,000 different accounts. If we have those two pieces of information, we can do a deposit in any of those accounts for any amount. Another example of a custom function is a function that just does something. And this one is dead simple. All it does is print a user interface, but it shows you the structure of a custom function, right? So we have the word def, which means define. So we're defining a function. We have the name of the function, followed by parentheses. If we're not adding parameters to that function, then those parentheses are empty, but they still have to be there. And then, of course, we have the colon. And then everything inside that function, that whole code block, everything that's part of that function is indented. And then when we call the function, we just use the function name, and we must include the parentheses. When we're actually doing this thing, when we want it to show menu, we say show menu and then parentheses. And the reason that we have to have those parentheses there is because if we just have show menu with no parentheses, it's going to look for a variable called show menu. The parentheses are how we tell Python that we want it to execute a function called show menu. Okay? So that's why they're there even when they're empty. So let's take a look at this in code view. And I've got examples for all of this code in one file, like I said, on Canvas you can download. Right now, everything is commented out so that we can execute one part of this at a time by uncommenting it. So let me uncomment this part. We can take a look at it. So we've got, just like before, def, show menu, parentheses, colon, everything is indented. It's just a bunch of print statements that just prints out a little header for a program. And here is where I actually call that function or execute that code that's in the function. And there it is. Now, if I have show menu twice, it will execute that twice, and so on. So that is nice because if I have a program where for some reason I want to show this menu 6 different times during the program, I don't have to type all of these lines 6 times over and over. I just define the function once, and then every time I want it to do that thing, I just call the function. It makes it a lot easier and it makes my code a lot more compact. Any questions so far? Okay. Seeing none. So now we're going to go a little bit deeper here, and we're going to introduce a parameter. Same function, but instead of just having a quote here, like I did before, notice. So this is what it prints. These are the words that it prints right in the middle of it, centered in the column of 80. Welcome to the ATM. Instead of that string, I have a variable called strMessage, and that variable is one of the parameters. So what that means is whatever I put here when I call that function will automatically flow down into that print statement and will become the words that get printed. So now I can change this menu every time I call it. I can have it do something different. So in this case, it says happy birthday. In another case, maybe it says something like hello everybody. Okay, so there's the message, gets defined there, and it gets inserted here as a regular variable. And so whatever I put here becomes the message. So now when I run that, it says hello everybody. But I can do it a second time and change that text to goodbye. And now it will run it twice with different things there. So parameters are very useful. And a parameter can be any type of variable or object. The other thing that's good to know is that strMessage as a parameter, as a variable, only exists inside this code block. Watch, if I try down here, print strMessage, okay, it's already underlining it in red, but let's run it anyway. So it prints hello everybody, does the menu, but then it gives me a name error that says strMessage is not defined because strMessage only exists inside that function. As a parameter, it only exists in that function. So far we have a function. A function, you sort of think of it like a black box. You don't really need to know what's going on inside that function. In fact, I could write a function and never tell you what's inside it. If I just told you it needs these parameters and this is what it does, you could still use that function. And that's sort of the idea of a lot of the functions that we write in Python should be self-contained like this. People shouldn't have to worry about what's going on inside. It should just work. And so as we're writing functions, we want to think about it that way. Could somebody use this if I just told them the parameters and the return values? Now, maybe a function might not always return something. Sometimes it just does something like print to the screen. But often, a function will be written like this. This is a basic function called do addition, where it takes two parameters, two integers, int number one, int number two. And inside the function, it creates a variable called int answer equals int number one plus int number two. And then we have a new statement here called return. When you want to send something back from a function, you use return. And instead of printing it to the screen, it sends it back to that code where it was executed. So whatever variable's int answer gets sent back via return. So when I call that function, I could do it like this, where I say int number, not the same here, but an external variable called int number equals do addition 2, 3. And so when I execute this code, it will print the number 5 because it's going to take those two numbers, plug them in here, add that, and then return it to that variable. And I can do anything with that variable. I don't just have to print it out. I could plug that into another formula. I could do something else with it. It's a way of reducing the code that's more complex to something that's very simple. Add these two numbers, in other words. You also notice here that so far, my function names have been pretty carefully chosen. to let people know what it is that function does. Show menu, do addition, whatever. So when you think of names, that's a good thing to do. I also use camel case in the names just to help separate the words and make it more readable. So I mentioned that variables defined inside a function only live inside a function. But what about this case? I have a function called show vars or show variables. It takes no parameters. And inside that function, I'm setting x to equal 33. And then it says print right now x equals, and then it prints the value of x. When it prints this, it's always going to say right now x equals 33. So if I use that function in this code here, where the first line of the code says x equals 20, then it prints x equals 20, and then it executes that function, or I call that function, where it sets x to equal 33, and it prints right now x equals 33, and then it prints print x equals, how many of you think it's going to say 33 there? How many of you think it's going to say 20? I've stumped you all. So let's look. Let's look and see what it does. Because this is a little bit ambiguous as far as behavior goes. So this is that exact code. And when I run that code, interestingly enough, even after we run the code that sets the value of x to 33 and prints it out as proof, x is still equal to 20. The reason for that is that inside this function, this x right here, even though it's identical in name, this x only lives inside the function. That's called variable scope. The scope of this variable is limited to that function. This x is what we call a global variable, which means it is accessible to the higher level of the program, the main thread of the code. So this x is the global x is equal to 20, and it stays 20 because inside the function, I'm setting x equals to 33. That's just local to that function. Okay? So there is a way to change that rule. I'm going to explain it to you with the caveat that you should use it for as limited a number of cases as possible. Most of the time, when you use this rule or you use this statement, you could probably, instead of using this, use parameters and return values to get information in and out of a function. But if I do this, inside the function, if I say global x, what that means is, from now on, if I use the variable x, I am going to be using the global variable x. So if I run this code, I get a different result. So there's my global x right here. And if I run that, now you can see that on this last line, x equals 33, because when I go into show variables, I set global x, and then I change the value of x to 33. I'm no longer just changing that local variable, I'm changing the global one. The reason this is risky is because you may have more than one function that wants to interact with that data. And if you set both of those functions to have global variable access, you could start having functions that are overriding each other or having conflict with some unpredictable results. It makes debugging a lot harder if you use a global If you don't use a global, instead, if I wanted to change the value of x after this, I could return a value from this and then set x outside that code to that value. So I can use a parameter to get data in and return to get data out of a function. And then I have a lot more control over what happens, but it's also really easy to debug. If something goes weird and the value of x gets changed, I can see exactly where that's happening every time without having to set a million breakpoints and step through my whole program to debug it. So it's a lot easier to debug and it's a lot safer, but it does have a trade-off because sometimes using global is just so much easier. So you'll see me occasionally when we're doing programs with custom functions, which is basically what we're going to be doing moving forward. Occasionally, I'll just use the global because I don't want to deal with all of the extra coding that's involved. But for the most part, if you want to get data in and out of a function, it's better to use parameters and returns. So just a couple more, really one more concept here, and that is the optional parameter, which involves giving a default value. So when I define that parameter, so message is required, it doesn't have a default value, times is equal to 1 as a default, which means that when I use the function say, it'll print the message that number of times. So if I do say hello, it's just going to print hello 1 time because the default value of this is 1. I can leave it off and it will figure out what it wants to do. I can also include it. If I say world and I tell it to do it 5 times, it'll print world 5 times. So looking at that code, right? If I run this and I put a new line character at the end of world, so it prints it vertically. So it prints hello 1 time, which is the default, and then world 5 times, which is what the code tells it to do. Now, I could make both of these a default value, message, hi there. Okay, so message is now an optional argument, which means I don't have to supply any parameters if I don't want to. So when I run that without any parameters, it just says hi there 1 time. But then if I want to supply the parameters, I can override it with a string and an integer. And I can do it that way too. Okay. So now, in this case, let's say I leave off the message, but I want it to print some hi there 5 times. So if I only provide it with 1 parameter and both of them are optional, then it takes the first parameter that I give it and it plugs it into the first optional parameter slot. So if I want it to print hi there 5 times, the way I would have to do that is I would have to name that parameter, and then instead of printing 5, it prints hi there 5 times. So if there are more than 1 optional parameter, I have to use the name of those parameters, or if they're optional parameters and I want to do them in a different order for whatever reason, I have to name them. So in this function, it's a func, and I have an A, a B, and a C parameter. A or B and C are optional with the default values of 5 and 10. If I print this line, where it says A is the value of A, B is the value of B, and C is the value of C, I could call it like this, 3, comma 7. So the A becomes the 3, 7 becomes the value of the next optional, and then C goes to the default value because I didn't name a third parameter. If I wanted to use the default value of B, then I would put 25 for A and C equals 24, and then B would be printed as 5 because it would go to the default value because I didn't name it. And then if I wanted to name them out of order, I can't honestly think of a reason that you would do this, but you could. Just keep it in mind. So for this unit or this module, the challenge is, or the assignment is, to make a game of rock, paper, scissors where the player chooses rock, paper, or scissors, and the computer randomly chooses rock, paper, or scissors. And you play the first person to win 2 out of 3 games or rounds wins the game. Okay, after a winner is declared, the program should ask if the user wants to play again. You must use at least one function in your code somewhere. Okay, more would be better, so you can practice this, and there's opportunities for several. So I'm thinking of different functions that you could use in this game. You want to think about who are the different actors or the different personas in the game, what do they do? So I can think of 3, at least, actors in this game. One is the player. You have to get their guess and clean up their input for rock, paper, scissors, because you need to account for if they choose to type in rock in all capitals, a capitalized rock, a lowercase rock, the letter R perhaps, or whatever else you assign. So you want to think about user interface, but controlling their input. So that could be a function where you get their user input, clean it up, and you return the cleaned up value. The computer player doesn't need any input, but it has to send back or return rock, paper, or scissors in a format that matches whatever you cleaned up the player wants, so you could compare them. So you could say, this person has this, the computer has this, which one wins, or is it a tie, that sort of thing. You also need some way to judge who wins. So that could be a function. Could be a function where the 2 parameters are the player's input and the computer's input, and you return who won or something like that. So lots of different things to do, or ways you can go with this. I'm going to let you puzzle with it a little bit because I want you to start thinking about how you can use functions intelligently in your language. There is one piece of this, and this code is also on the website or on Canvas. This is how you can generate a computer guess. I will give you this function, okay? And you don't have to use it as a function, but I stated it in a function so that you can see how it works. You need to import random again. This is a function in a random module, and you'll create a list. Just use this format. We'll be talking about lists very soon in this class. We haven't covered them yet, so you don't really understand necessarily what this means. But inside the computer hand function, I'm defining a list that has 3 elements, rock, paper, and scissors, as strings. And then I'm using the random.choice function from the random module to choose one of those elements. So random.choice will take a list as an argument, and it will return a random pick from that list. So it'll take that and it'll return it back to the main code where it's printed. So if I run this, each time it will give me a different rock, paper, or scissors. So now you have basically everything you need to be able to work this out. This could be done completely without the use of functions. I will say that. You could do this whole program, no functions, but I want you to use functions in this program. So figure out where you want to use functions. Think about the structure of the game. Think about how the game will flow. Sometimes I take out a pencil and a piece of paper and I sketch like the loops and how the program flows so that I can think it through in a visual way before I start writing code. That's okay to do too. Again, think about the big structure, start with some comments, kind of lay things out, and then start filling stuff in. Okay? And that's how I'd recommend approaching this problem. But so far in the class, we've covered everything that you need to know in order to get to this point. So you should be able to do this. It might take some struggle, but if you have questions, ask the questions. If you need me to look at code, let's look at code. This is a good program to start getting into the more complex work of developing software. So I think that's about it. Any questions on anything so far? Okay. I just want to remind you that March 12th, assignments 1 through 5 are due. Hard deadline for those, because if you get to March 12th and you haven't done at least through assignment 5, which was last week's assignment, you're probably not going to be able to catch up in the class. So if you're struggling, if you're behind, don't just ignore it and pretend that it's going to get better, or I'll just do all the work later in the class. Let's sit down and let's get through this stuff, because I want to make sure that everybody's able to progress past March 11th in the class. Okay, so that's it, and you have some time to work now. You've got almost an hour to work on this, so go ahead and get working and let me know if you need any help.